Okay, this is lecture 21, which is the exam 3 review, and I'm going to go over problem number 1. Okay, so problem number 1 says a sample of 30 companies was randomly selected for a study investigating what factors affect the size of company bonuses. Data were collected on the number of employees at the company and whether or not the employees were unionized, 1 if they were, and 0 if they were not. Below are the multiple regression results. And so as you can see here, you've got a multiple regression table and a scatter plot. Okay, so the first question is asking to write out the estimated regression equation and which variables are significant in the regression equation using an alpha level of 0.05. So the first thing we want to do, if we want to write out a multiple regression equation, we need to come back up to the table, and we're going to use these coefficients and these variables. And so what we're going to do, we're going to always have our constant, and so we're going to take the constant coefficient, which is 347.9, and we're going to add that to employees with a coefficient of 0.6547, and we're going to add that to union with a coefficient of 1259.5, and that will be our multiple regression equation. So as you can see here, that first line has our constant, and then it has our employee variables and our union variable with their coefficients out in front. And so the second part of that question was asking which of those variables are significant. So when we're looking for significance, we'll go to our p-value, and we were given an alpha level of 0.05, so a variable will be significant if it is less than that. So as you can see here, we have a p-value of 0 and a p-value of 0.047. Both of these are smaller than 0.05, so therefore employees and union are significant in this equation. And that is my solution to number 1. Okay, so let's go down to number 2. I'm sorry. All right, so number 2 is if another variable, which would be yearly revenue, was included in this multiple regression model, should collinearity be suspected, and if so, what would help determine whether this is a problem? So what we're going to want to do is we're going to want to make 3 new regression models and check the sign and significance for each one of these. And so for these regression models, we are going to compare our new variable, what we want to add, which would be revenues. We're going to compare that to annual bonus, since that is our dependent variable. We're also going to compare an existing variable, which would be we'll do employees, and we're going to compare that against annual bonus. And we're going to take the interaction term between employees and revenue and also compare that to bonus. And so we're going to have 3 different models that we're going to be able to look at, and we're going to check the sign and significance for each of these. And so I can show you my solution to that. We weren't required to actually go through the work for this, but you check the sign and significance for each of these models. So they're being compared against our dependent variable, which is bonuses, and so that's the new variable we wanted to add. That's the existing one, and that's the interaction term. So as you can see here, if there is any change in sign and significance, then that means there's collinearity between revenue and employees. So you will have to do a little bit of math and get the values for that, and then you'll be able to check and see if it is significant or not. Okay. Then question number 3 is to interpret the coefficient of union. So what we want to do, we want to go back up to our table, and here are our coefficients, and this is the coefficient for union. One thing, what we'll do, we'll go and use our multiple regression equation to interpret this. One thing that is important to note is in the problem, we were given a choice of 1 if we were unionized and 0 if we were not unionized. And so we're actually going to plug that in to our equation, and that will affect the value for unions. I'll show you what I mean by that. So the answer I put was the bonus is 1259.5 more for unionized companies compared to non-unionized companies. And the reason for that is if we were to have a unionized company, we would put a 1 here for this variable. And so it would increase our dependent variable, which is bonuses, by 1259.5. However, if it was a non-unionized company, we would put a 0 here for this variable, which would wipe this out, and it wouldn't exist. So the answer to that would be there. The bonus is 1,259.5 more for a unionized company compared to a non-unionized company. And like I said, you just get that from going to your table. Okay, and so question number 4 is, based on the scatter plot, do you think using union as an indicator variable in this model is appropriate? So it wants us to go up to our scatter plot, and it's kind of hard to see right here, but this says union, and it's a 0. The blue line is a 0, so if it's not unionized, and the orange line is a 1 for if it is unionized. And so one thing we want to look at is these two lines have a different slope, and so that tells us that there's an interaction between union and employees, and the reason it's employees is because that's what we are comparing it to. And so since we can tell there is an interaction between these two, since there's a difference in the slopes, we might want to add an interaction term to our model to make it more accurate. And so I will show you my solution to that. It said since the slope changes, that means there's an interaction between employees and union. Therefore, the interaction term union and employees might be appropriate for this model. And the keyword is might. We would still need to test the significance or the p-value for that once we added it in our model to see if it was appropriate or not. Okay, the next question, it says an alternative multiple regression model is fit to the data and the results are shown below, and which model is better? So we are given a model, we're given one model here, and we've got one at the beginning of this problem. One thing we want to look for when we are comparing to see which one is better, the main thing we're going to look at is this R squared value. We want R squared to be as close to 100% as we can get it, because that shows how reliable our model actually is. So we can go to the first model, and we see that we have an R squared value of 62.4%. So this model is 62.4% accurate. And then so obviously if you go down to the new model they gave us, the R squared value jumped up to 70.6%. So it's easy to see that the second model has a higher R squared value. It's closer to 100. So this model is it is more accurate than the original. Another thing that you might notice is they added a new variable, employees times union. That variable is not in the original model, and this variable based on the p-value is significant since it's less than 0.05. So that since that is a significant variable, that is just further improving the accuracy of our model. And so the second model would be the more accurate, therefore it would be the better model out of the two. And you can see there is my solution to that. So the second model is better since R squared increased and the interaction term is significant. Including the interaction term improved the accuracy of this prediction. And finally, using the better model, predict the annual average bonus for a company with 7,500 employees that are not unionized. So it's two things we want to look at is 7,500 employees. That's what we're going to plug into the employee variable, and not unionized. That is key, because if you remember at the top of the problem, it's given us a 1 for if it is unionized and a 0 for if it is not unionized. And since we are not unionized, we're going to plug a 0 into the union variable, which would essentially, it's going to end up canceling it out. And so, let me go down here. Oh, went too far, sorry. Okay, so we're going to use this new model. We have to set up a new regression equation since we're using a different model. So we're going to have a coefficient of negative 1,241. We're going to have the variable employees with a coefficient of 0.8872. And we are not going to include union or employees times union, since we would just be putting a 0 for those variables, which would take it out. And the dependent variable is the annual bonus, and so that is what we are solving for, is the average annual bonus. So as you can see, you've got your constant, so that's negative 1241, and then we've got the employee variable with a coefficient of 0.8872, and then when you plug in 7,500, which is what was given in the problem, you'll get 5,413, which is your final answer. And that is all for question number 1.